All right. Hello, everybody, and welcome to the stream. We are doing a extra stream today. We missed our stream on Wednesday, and it was kind of out of my control. So what I'm doing is we're going to have a little bit of a makeup stream today, and we'll see how long we wind up going. I have a few things on the agenda that I want to go ahead and work out. So before I do, though, I do want to take just a quick second and thank all the supporters of the channel, starting with our partners. Those are the highest tier of subscription on Patreon and YouTube. That is A.R. Slia, Gerbolis Inc., Patrick Kuhlman, and Wen Cheng. Thank you so much for your support. I would also like to list off everybody else here and thank them under the supporter section. That is all of the other tiers on Patreon, as well as YouTube memberships, and of course Twitch subscribers. So thank you all very much for your support. It is greatly appreciated. Of course, it goes without saying that I appreciate each and every one of you who follow me along on whether it's here on Twitch or on YouTube or both. Of course, your support is greatly appreciated as well. So the idea with this stream, for those of you who are new, is this is to be an interactive stream. So we are developing a game engine basically from scratch here using C and Vulkan. And the idea is that this is supposed to be a learning exercise. Not only for folks out there, but also just building one of these things, of course, is a learning exercise along the way for the person doing it as well. So I've written many game engines before. This just happens to be the largest project I've worked on my own. I've written 3 commercially before that. Yeah. So anyway, to give you an idea where we're at, I did go ahead and do a little bit of camera off work since the last stream. The last stream we put some debug displays into our engine, preparing for an editor. And so I've gone ahead and done a little bit of extra work. You'll note here that I have VS Code up. I just use that for debugging at the moment. So I'll go ahead and bring up a scene here that we have. And you can see right away some of the changes that we made. So last time we added this grid here, and we added these debug boxes so that we can see where lights are in the scene. And they're, of course, tied to the position and the color of the light. So we have that working in an animated fashion as well. Since then, we've also gone ahead and fixed some issues with our imported static meshes. They were not calculating bounds correctly or extents correctly. And so I went ahead and put in some fixes for that. We'll go over that in a second. And we went ahead and used that data to highlight the bounding boxes of our meshes too, so that we can see where those things are. It doesn't just mean that we're going to use it just for that, though. We're also going to use it for things like object picking and eventually even physics down the road, right? So these extents will have a lot of uses going forward. We can see here that it's around this car mesh and then also this great big sponza mesh. I don't have sort of sub-mesh boxes being highlighted at the moment. Although that would be easy enough to add, I just didn't see the value in doing it just yet. But all of the sub-meshes, like this Sponza one has, I think, like 300 meshes or something like that, sub-meshes underneath of it. And so, if we wanted to, we could put bounding boxes around each one of those as well, because they all additionally have extents on them, and then the extents of those extents are used for the outer object, and that's how we get that. Okay? So I hope all that makes sense. There is one more thing that I added, which is before we had the debug grid and then we had the debug boxes, we also now have the capability to add a debug line in 3D. So it might be a little bit harder to see in this example, but we can see here that we have a line coming out here from the origin. And this is for the directional light to tell us what color that light is, as well as what its direction is. So it gives us just a little bit of a visual cue there. I also added a third axis to the grid. So if we wanted to take a quick look at what, or maybe be able to see this light a little bit better, let me unload the scene real quick and go over here and open the level. And I'll change the color of the directional light to, I don't know, something way more red, right? And I'll just write that out and then reload the level. And you can see it here much more clearly, right? So that much more, it's much more obvious as to what that color and direction of the light is, right? So this matches that. At some point, we may have maybe just a few of them, maybe around in a circle or something like that, just to make it a little bit more obvious. Or maybe I'll make the line longer, but at least for now we have that, right? Cool. So that is the recap of where we're at. Let me just check chat real quick. First time chat, Anton the Eater. I have one question since I started watching the Kohi series. Why are you using C and not C++? I always thought C++ was standard for game engines. So I have several reasons for that. One of those reasons is I don't heavily use object-oriented programming, which is one of the biggest things that C++ adds to C. I also don't use things like operator overloading or function overloading, things like that. Most of the functions that C++ adds, I frankly don't use. C is a much simpler language, and it's capable of doing everything that game engines require. And there are many game engines out there that are written in a very C-like style, even though they use C++. I don't use the standard template library. I don't have use for any of that stuff. I roll all those containers myself because I have complete control over them and can profile them and fix any issues that I find. And I also have I also maintain control over my memory, and so it gives me greater debuggability to use my own structures. So those are some of the reasons. Also, C compiles a heck of a lot quicker. So if you wanted to, you could technically follow this series using C++ and just port it over as necessary. There's not that many differences. So you certainly could do that if you wanted to. Hope that answers your question. Cool. So that is basically all we've added, at least visually, right? So I'll go ahead and quit out of that real quickly, and I will go ahead and bring up a diff of the things that have actually changed that I did off camera. It's not... This looks like it's actually a lot more code than it is. Let me get this Vim out of the way for a second as well. So these are the files that changed. So basically all that I did was under resources, I moved all the debug resources under a debug folder because it just makes it a little simpler from an organizational standpoint. It cleans it up a little bit, right? So we have the box 3D and the grid that we had before, and now we have this new line 3D CNH file that we'll touch on here in a minute. We also made some changes to mesh, as I mentioned before, resource types, and our simple scene to load in those debug types. So the first thing is box 3D C. Actually, I think this was just a formatting change is all that was. It looks like it eliminated the last line in the file, so that's nothing really to look at there. Otherwise, there was no real change there. So all these, actually, the only real change is the movement of these. So really, these 4 files here are going to be what we're going to focus on. So the debug grid, I added that third axis, as we mentioned, but I also added to our config a option to use the third axis. So we can actually turn that on or off in the configuration. So if we don't want that, say we're using it in a orthographic perspective viewport or something, we wouldn't necessarily want it for that, right? So we can turn that off. And then I added some logic basically to handle that, whether that's on or off, right? And so with that, we have a line length 2, which basically uses the longer length of the 2 dimensions to draw that third line. And then here we go ahead and we select the element index 2, right? So it's basically whichever one wasn't being used for each of these orientations. And then if we use that third axis, we actually add the third axis line immediately after the second axis line, but before we actually go and generate all the other grid lines, right? So all that is the same as the logic above it, right? It's just in that third direction instead. The only other thing is we had to make a small tweak to our for loop here because that was hard-coded at 4. That's because we had 2 points for 2 lines. But now we could either have that or we could have 6, right? So if we're using the third axis, then we're going to start at 6. Otherwise, we start at 4. So it just modifies the for loop for that. Looks like most of these are formatting changes, so we can skip over that. And then the debug line 3D is pretty much as simple as you would expect it to be, right? So all of the creation, the destruction, the parent setting, all that stuff is the same exact as it is in the other objects there. But the main portion of this is that we only have 2 vertices that are supported in this guy. So we have 0.1 or 0.0 and 0.1. That's really the only difference. So our recalculate points is literally just 2 lines of code, right? Instead of drawing a box, we're just drawing a line. So this just kind of packages that up a little bit. It makes it a little bit easier to work with. And this, of course, is the header file for that. And then our mesh.c, this was, again, some formatting changes just to rearrange the order of those includes. And the biggest change is actually here within our mesh load job success. So once the resource has been loaded from disk and parsed out, then we go ahead and we calculate the geometry extents. So this is done on each of the individual sub-geometries, right? So we do that for each one of those. And then we go ahead and we compare that against whatever global extents we have, right? And that is against the mesh, the outer mesh level. So the local extents are against the current geometry that we're working with, sub I, right? And the global is against the mesh itself. So basically just as it's calculating the extents for each mesh, it compares those extents and says, hey, if any of these are outside the min and max range, just update the min and max range. And that's how we get that whole outer, the outer extents. Nothing terribly complicated there, right? It's pretty straightforward stuff, I think. The only thing that we had to change in resource types was we added debug data and extents to the mesh structure so that we can actually attach the debug data to that. And then the simple scene, we added line 3D in here and box 3D. For some reason that wasn't, it was down here, right? So the formatting just kind of moved that up. And here we just added to our grid config that automatically gets created during the scene creation to just use the third axis. And then we come down here to simple scene initialize, and within the directional light, we go ahead and allocate for our debug data, and we go ahead and fill that out and create a line there, okay? So the debug data for that is a line. We go ahead and add here the initialization code for that, and then here is the loading code for that, right, in the simple scene load. The simple scene update, this basically just double checks the generation and updates the color, right? So it makes sure that the geometry is actually loaded, and then updates the color for it. And that is basically the same as we're doing with the boxes, where we have, if you have changing light color over time, just make sure that that's up to date as well. And then further down, for each of our meshes, this is where we are actually kind of doing the same thing. So we set up our debug data, we create our debug box for the mesh using its extents. We set up the transform for it. We go ahead and initialize it. We go ahead and load, and then we set the color and the extents here, right? If we are unloading, then here is the. Wait a minute. Is this unloading or? No, sorry. This is building the render packet. Let me see. Extend this up a little bit more. Okay, well, I'm not going to go all the way, but this is basically within the, while we're building the render packet to send off to be rendered, right? So we've added a section here for the directional light to add that debug geometry to that list. And then we also added it for meshes as well. So we can see here that we're only doing the outer mesh, but yeah, that's that's pretty much that. So if we were to add sub meshes to this, we would basically loop through those sub geometries in here and add them that way. All right. So this is within directional light add. So if we add one dynamically to the scene while the scene is actually already up and loaded and running, this just handles that. And then of course, if we are replacing the light, and there's already a directional light and we're swapping it out with a different one, then we make sure to unload and destroy the old debug information. And then if there is nothing to replace it, we free the memory for that debug data. If there is something to replace it, then we go ahead and we not only add the directional light, but we create the debug data, and then we come down here to actually create it. So this looks like similar to how we actually handled it in the level initialize, right? So we create it, we check to make sure that we're in an initialized state. If we are, or past that, we go ahead and initialize it. If we're past the load state, then we go ahead and load it. Here's the unload when we remove the directional light, so we remove that geometry as well. Then we have the mesh remove, so we remove that geometry. And then we have the actual unload, which handles the unloading of the mesh geometry there, and the line unload for the light there. Let's see. DJ Turfy, thank you so much for the follow. I appreciate it. Thank you. And then the only other thing is some pathing updates in our includes to include the debug path, right? So that is all that's in this that we've added off camera, right? Not a whole heck of a lot. So I just wanted to go over that real quick, because what we're going to do is we're going to mark that branch or that set of features as done for right now. And we're going to take some additional steps towards creating the editor today. So with that, I think I can just go back here. And so these are all the commits that we've had on this branch, right? So we've changed a lot of stuff to support this. So we can go ahead and... I don't know why I'm getting double notifications on OBS. That's very strange. Anyway, so we'll go ahead and create this pull request. So this is going into the main branch. Looks like we have some merge conflicts. Fun. Okay. So let's take a look at that real quick, because I'm not sure what those would possibly be. Let's merge main into... Really? I have a... Oh, I thought I stashed these changes. Oh, because those are on... All right, okay. What was that? Grids and boxes get merge main. Let's see, what do we have here? Oh, really? It's over the transform? We want to go ahead and take current change. I'm surprised we ran into this, actually. Okay, so in this case, we want the current change. And I think that's also going to be the same here. Yes, we want the current change. Okay, So that should fix that. And then the pipeline, it's got a couple of these as well. Why would we need the shader system here? Let me see what these other conflicts are. Okay, so we definitely want the current change on this one. And we definitely want the current change on this one. So I guess we want the current change on this one. All right. I'm just going to clean and rebuild real quick and test this before I actually push it. I'm really not sure how I wound up with merge conflicts. That's really strange. Okay, so it looks like all that stuff is working. By the way, if you guys have any questions or want to bring anything up, feel free to do so. This is an interactive stream, by the way, so feel free to jump into chat there. Okay, so it looks like all of our changes are here and it runs correctly. Let me quickly also test the loading and unloading. All right, unload, load. Okay, so I think we're good. So, all right, yeah, so we want to add these guys just because I don't feel like typing that manually. Up to date. Merge from main. Okay, so in theory, we should be able to go back to our branch now. And refresh this. Okay, so merge conflict is resolved. So now I can just squash and merge. And we should be good to go. Okay, cool. So all of this stuff now is in the main branch for you guys to go ahead and pick up. Tammin, hey, it has been quite a while. How are you doing? I see some Vulkan. What are we doing today? Yes. So what I was doing right there was I was just reviewing some off-camera changes that I made to add a little bit more debug stuff to our scene. So we added some visual boxes around the extents of our objects, and then also something to indicate directional light, the actual direction, right? So we've added that, and now we can actually move on to stuff that is more editor centric, right? So let's see, I want the refactor render view branch. Okay, and this is a branch that I've kind of started a little bit of research and work on off camera. Merge main. Ugh, more merge conflicts. Okay. Oh, it's the same conflicts. Let me just resolve this real quick, and then I'll go back to my description. So, accept current. We want current on that one. We want current on this one. Current on this one. And then current on this one. Current on this one. I know I could just say accept all current, but I don't like to do that. I like to do it manually. Status. Okay, so get, you know what, I'm just gonna add these up here because that's a little quicker. Okay. Get, commit, merge from main. Okay. Now we should be good. All right, so I can get rid of this and come back to here. All right, so what we're going to be doing today is taking a look at our render views because I was thinking about this a little bit off camera, and we need to change some things to make stuff a little bit more flexible. Editor, are we going to start doing UI? Yes, UI is going to be part of this. And so that's actually going to be a topic all of its own for sure. But yes, UI is going to be definitely part of it. Okay, so what we have right now is we have these views that we use where we build up packets, render packets, using those views because they're aware of what shaders they use and how things should be drawn and things like that. And then we fire those packets off to the renderer to be rendered, essentially. And what we've done is we have come up with these sort of known types, these sort of built-in view types that the engine comes with. And the idea initially was that the application could just use those and kind of configure them to what they need. But then I got thinking about it, and I'm like, every application is probably going to have different needs. And more than likely, we aren't going to be using a lot of those sort of predefined types. And so it makes more sense for those views to actually exist in the application's game code, or perhaps another shared library that the applications use. And the reason for that is because we don't want to sort of limit these things to having a predefined structure that they must follow every single time. It should be up to the application to say, hey, maybe I don't use skyboxes. I don't need that pass. Or maybe I don't use the pixel perfect object picking. I don't need that. And so it should be up to the application to configure those things and use them or not use them. And if the application doesn't need them, frankly, the application shouldn't even really include them, right? And so I think what I'm going to do is I'm going to take the concept of having known view types and I'm going to wipe it out. We're not going to have that. And instead, we are just going to do what we call register views with the engine, with the view system, and let it just basically let the application do all the configuration on the application side and let the engine be completely ignorant of how that works. And so that is basically what we're going to do today, is move those views to the application. And the reason that we're going to do that and the reason we're doing it now is because I need to add a new view that we are going to eventually use for the editor, right? And we're going to build it in testbed for now, but we're eventually going to move that over to an editor. So yeah, that is basically the reasoning behind that. I do see here that we have ads that are going to start here in about 20 seconds or so. So before I jump into this, I will sort of take an ad break. Let's see. I don't know how to pronounce your name, so I'm just going to say Polize. I finally catch you streaming. Yes, welcome. First time chat. Glad you could make it. All right, cool. So ads, I will be... Yeah, if you're subscribed, there's no ads. Got another 45 seconds on ads, and then we can move on. Twitch's timing sometimes for the ads can be a little bit weird, and I'm not sure that you can actually hear this or not, but yeah, it tells me that ads are coming soon, so I might have actually triggered this screen a little bit early, but we're almost done. All right, so we are done with ads. Yeah, so as I was saying, ads sometimes can be a little bit weird in terms of timing on here. I haven't completely figured it out yet. But sometimes I trigger the screen a little bit early. You updated your name. Nice. Do I play Diablo? I have not played Diablo since Diablo 3. Yeah, I haven't played Diablo 4 yet. Better to pronounce now. Yeah, hamster dev is definitely easier to pronounce. All right, cool. So, where were we? All right, so I had this to-do in here. Temporary, make factory, and register instead, right? Because the engine, or the render view system has to know about these things ahead of time. And it's not really great, right? Like, I really don't want the view system to have to be aware of these types. And we have all kinds of other stuff down here that is a little bit fallout from that too. So, we have, again, to-dos here. And we basically look at its type and then say, okay, well, we assign function pointers that way, right? Like this is not something that's going to be sustainable, right? We did it sort of as a temporary, just to kind of get things up and running. But we now need to kind of get in here and fix it, right? So this is primarily the reason that we're going to do this, so that the system is a lot more flexible. We can add and remove views as we need, and go from there. So what we're going to wind up with is we are going to remove this render view system create. We're going to remove the concept of config, and instead of having a config object, all this configuration will be done by the application, and the render view system will say, application, give me all the views that you have that you need to be registered, and we will go ahead and do that, right? So that is the way that is going to work, and that is what we're going to work on today. And again, the reason that we're going to do that is because I need another view. So I guess before we actually jump into that, what I could do is briefly describe why I need that. And I think I still have... Do I still have the image up here? I'm not sure that I do. Yes, I do. So let me just pull up an image of what we're going to be making. So this is the reason that we need another view, is because we want to have a debug specific view for a Gizmo, right? This is one of the things that we're going to be developing. Now, I know a lot of people tend to just kind of use an existing Gizmo that is created for us automatically with an external library or something. But on this stream, that's not the way we roll for most things. We are going to make the Gizmo ourselves and go through the steps to actually make that Gizmo, right? And so for those of you who aren't familiar with what a Gizmo is, or haven't really used one, a Gizmo is basically where you select an object and you have the ability to manipulate that object. So typically you have 3 to 4 modes with a Gizmo. So this is a move mode where you can move it along the X, Y, or Z axis. This is the one out of 3D Studio Max. So this one actually has Z pointing up, which is not what we have. Y and Z are reversed in our case. But so we're going to wind up with one that's very similar looking to this. And then if you actually click this and drag it, you'll move in the x-axis. If you click this and drag it, you move in y, and so forth. And if you click in this sort of boxy area in between the two, then you can move along two axes at once. And so that is basically the way that's going to work. So that's the move mode. Then we have a rotate mode where the current axis that you're rotating on will be highlighted yellow. So in this case, it's the Z, which is also highlighted blue here. Again, ours will look slightly different because our Z doesn't point up. It points where Y is in this case. But that is the rotation gizmo. So that allows us to rotate things in the scene. And then we have a scale one, which we're going to make similar to this, where again, you could scale on one axis, go between two axes for 2, or if you want a uniform scale, you can sort of click and drag here in the middle to do that. And so this is the ultimate goal, and this is going to be in a separate view that's going to have its own render pass that sits on top of the world. And the reason we're doing it in a separate pass is because we want the gizmo to be present in the world and in the correct three-dimensional position, but we want it to be drawn on top of everything. So if the gizmo happens to go behind a wall, we still want to be able to select and manipulate the gizmo. And the only way we can do that is in a separate render pass that happens on top of everything else. So that is the primary motivation for all the work that we're going to be doing today, because this is to support another view that our editor eventually is going to need. So I hope all that makes sense. Image time. Yeah, exactly. All right. So with that, we are going to start moving some things around. So I'm going to go here into engine, source, renderer, views. And these views are all going to come out of here, right? So we have a few different ones. We have the pick, the skybox, the UI, and the world. The world is basically, we're going to wind up creating a copy of that one to use for rendering our gizmo. But we want to get all these things out of the engine and instead have them located in the application and then configured in the application and then to be rendered or to be registered rather with the view system. So I think probably the quickest way to do this is actually going to be to open like an Explorer window. So let me just open one of those here off camera. And let's see, we have under here. Move this down here so you guys can see it. So we have renderer views, right? And we want to basically, in fact, I'm going to cut this and we're going to go to Kohi. We're going to put this in testbed lib for right now. So we'll put this under, I guess right here under source, right? So we will paste one folder, right? And you can see here I've created an editor thing with a few things that I've done a little bit of experimenting with off camera. We'll get to those in a bit. So now our views are here. And that's the first bit of that. Actually, I can close that. Let's see. Okay, so the renderers had those things removed. I think we can actually close that now. And we need our render view system, right? Which actually we already have open. So let me get rid of this guy. And we're going to get rid of these. So we have a bit of a list here that I kind of came up of steps that we need to do to handle our refactoring. So we're going to change views to be owned by the application, moving them to testbed, for example. So this one is actually done. We're going to remove the concept of known types of renderer views. So that's going to be the next thing that we do. We're going to remove the concept of render view configuration, instead opting for the function pointers to be filled out by the application, as well as all the fields for the view, then pass them to a register function. Let's Blends just followed. Thank you so much. I appreciate the follow. So much code, yes. There is a lot of code to a game engine, and there's going to be lots more. It is a game engine after all. So, why is this bleating about? I don't think it likes the fact that I changed some of this stuff in a different editor. All right, so, oh, I got rid of my. All right, I'm just gonna write this file as it is. Okay, so that's the next thing we're gonna do, and then after that, the register function should take in a copy of the view, copy these values to an element of the internal array, which we already have, and register it by name in the hash table, which we already have, right? So we're really just moving some stuff around. Okay, so let's see. Probably the first thing we want to do is we want to get rid of the known render types, right? So where is this defined? Render types INL. So we'll go over here, render types INL, and render view known types. Okay, so we're going to take these, and we no longer have them. Okay, so we don't need that anymore because the application is going to take care of all this stuff for us. So we don't really need to have all this mess anymore. All right, so that marks this one done. Remove the concept of render view configuration, instead opting for the function pointers to be filled out by the application. So if we look at render view configuration, render view, actually it's right here. So we have a custom shader name, width, height, the known type, which we just deleted, the matrix source, the projection matrix source, a pass count, and then the render pass configs. So we're not going to be setting that up either. At least not in the engine, right? We're going to go ahead and set that stuff up in the application. So as far as that goes, I don't really want to remove this yet, but what I'm going to do is remove this, right? I'll mark it with a to-do so that we don't forget to do that. So I think probably the first thing we'll do is we'll move to the application now and start setting this stuff up. So testbed main, and I think if I remember correctly, this stuff is all the way at the bottom. Here. So this function right here is basically how we configure our render views. And this is one of the main things that we're going to be changing. So we set up these configuration structures. You know, it's a bit Vulkan-like, I suppose. And then we go ahead and push this to an array. And then that whole array winds up getting pulled in from the application config by this system here. So instead of us doing that, I believe, let's see, when is this called? So configure render views. So that is called an application boot, which I think is a little bit too soon. I think that's a little bit too soon because I don't think this system is stood up. So let's take a look at that. Systems manager, and we'll have a look. And I think this is actually in post boot, if I recall correctly. So we have the texture system, the font system, the camera system, and then the render view system config here. And then we load the views from app config. We call render view create from here. So I suppose what we could do is, instead of storing configuration in the app config, we could store the render views themselves. And then if we store the render views themselves, then we should be able to pull them the same way. Only instead of render view system create, it'll be a register. Because otherwise we're going to have to create another callback to the application, which I'm not really a huge fan of. Trying to think which would be the best way to handle this. Okay. So basically, whenever we call render view system create, we pass this config. It looks like we just take a copy of the data that's here for the most part, with the exception of getting the hash table. So I'm thinking we should probably pull the important parts of this out and separate it into our new register function, and then start from there. So let's go ahead and write that real quick. We'll just write it in here, and then we'll write the header file after we figured out the interface and all that. So render view system register view register. We'll just say register. And then we'll take a, you know what? Let's take a pointer to a view. We'll take a pointer to a view because the application is going to be creating the view. There's no reason for us to actually take a copy of that, right? Like the application could just hold it. And that way, if the application needs to access it for some reason, it can still do that. So we're going to take a pointer to that. And I'm going to come down here and grab all of this stuff because all of this is valid. Right, and we'll plop that in here. This should be view name, I believe. Oh, does view does have a name. Okay, so we'll look up view name. Let's change this. View. Okay. We go ahead and find an ID. Again, we'll change this. Okay. Max view count. Yeah, it should be fine. Okay. So that's the registration for that as far as the hash table goes. We will put a return true here just so that we cover that. Now the next thing that happens here is after we find that, we are obtaining a pointer to a view here in registered views. This, I think, is actually going to be refactored. So let's go to definition on that. Whoops. Really? Okay. So this is just an array of render views. We're going to change this to be an array of pointers. Array of pointers to views owned by the application. Right? So we're going to take ownership away from this system and leave that on the application as well. Which means we're also going to have to change anywhere that uses registered views here to treat that as a table of, or an array of pointers instead. Right. So we're registering a block of memory for this, plus the hash table requirements. Let's see the table block. Okay, so we need to actually update this. Our memory requirement for the array is now going to be render view pointers, so that's going to be considerably less memory on there. Go ahead and create the hash table. That should be fine. We are going to have to change this to be an arrow. That's probably going to be the most common change, honestly. Okay. Render view system shutdown. So I'm actually wondering, we probably shouldn't. I suppose we could do this, actually. We could call destroy from here still. I think that's fine. However, that doesn't need to be address of because it's an array of pointers. Okay, so that should actually be fine. There's not much change there. Register. Registered, this needs to be an arrow syntax. And I think that's it for there. Create, I'm not going to worry about that for right now because that is going to be going away. Although I guess it's had so many errors up there that it actually can't. It can't process this, right? So when we do a window resize, we need to also convert that and that. On resize, this should not be the address of. This should not be the address of. Packet build, view. Okay, that's already a pointer, that's fine. On render, that should be fine. Render targets, generate. View render pass count, okay. So that, I think this will all be fine. Okay, so I think we've changed everything internally that we need to change to support that. All right. Okay, so in register, what we'll need to do is, once we've verified that the entry was valid, we'll need to say state pointer, registered views, sub I, no, ID, sub ID, equals view. And you know what? This is actually not going to work. And that's not going to work because those are all going to be void pointers. So actually, we don't even need that ID field anymore. Because this is an array of pointers, we can just look at, instead of looking at an ID, we can literally just look at whether or not it's null. So we literally don't need this anymore. So we can save ourselves a little bit of memory there. So instead of looking at the ID, we can actually just say if not registered view sub I, and get rid of all of that. And that's how we determine that. ID equals I, break, and then we set that. Right, and the ID literally just becomes an index at that point. Because I don't think we ever actually look up by ID. Other than the hash table itself. The hash table will give us an ID that we use to get that, but I don't think we actually need to store that. Okay, yeah, that should be fine. All right, so this means that in the shutdown, we can also say if not view, or actually, sorry, if view, so if the view exists, then we destroy it. Destroy its render passes, and we don't need this line anymore. Do we have anything up here we need to change? I don't think we do. That should all be fine. Create, we're going to kind of skip that for right now. I know we've broken it, but that's fine. We'll come back to it. On window resize, so if registered views sub I, then we do the resize. It's a lot cleaner, I think. So go ahead and get the, so this one's fine. Packet, that's fine. These take, anything that takes a render view pointer should be fine. I don't think we need to worry about that. Okay, so I think we're good there. So that was an unintended side effect, is that we get to simplify our structure just a little bit, which is cool. Oh, initialize, I did miss something here. So we fill the array with invalid entries. We actually don't need to do this anymore, because it's just going to be filled with 0, because we're allocating that. I suppose if we wanted to be pedantic, we could say K0 memory, state pointer, registered views, and then size of render view pointer times typed config max view count. Actually, we should probably use state pointer, because that's already going to be set at that point. Oops. Make absolutely sure that the array is 0. Okay, cool. Am I working alone in the engine? Yes. There have been a... oh, ads. I will answer that question in full when we get done with ads. ads are almost finished. We got another 20 seconds. All right, cool. So to fully answer your question, yes, I am working on it alone, but there have been a number of other people who have contributed PRs in the past. I actually do have some open pull requests that I need to review that have some fixes and stuff, but these are the folks who have contributed code other than me that has been accepted. The biggest one here was probably Jad. He basically created the original sort of unofficial Mac port, which I heavily based the official Mac port off of. And so that was really cool of him to add that early on support. And then I was able to take that and make it full-blown so that we could run on all three platforms. But yes, it is primarily me. There have been other people that have added to it, but yeah, it's 99% me. Okay. So, we've made sure that this is zeroed. So, I think that is all we need to do for that. Okay. Crate's still broken, we know that. All right. So let's figure out some of the other stuff that our register has to have added to it. So we've added it to our hash table. We've added it to the array. Let's see, is there anything else in my notes here that we had to add? It says we were going to take a copy of the view. I'm not going to do that. I'm going to hold a pointer to it instead. So this is actually done. Working a little bit out of order, right? But the biggest piece is actually going to be this third one here. So I'm wondering if we even actually need this onCreate to be done. I suppose we could just call it anyway. Because see, we set up these function pointers and then we go ahead and we pass onCreate. And then I suppose we could change onCreate to onRegister. Maybe that's the way we do it. And at this point, we also regenerate the render targets. So I guess we'd have to do that. And then we update the hash table entry, which we would not necessarily actually have to do. Wait, did we actually do that already? Oh, we got it, but we didn't update it. Okay, yeah, we actually do need to do that. So that would have been a nasty thing to miss. So we'll do that right here. Right there. Let's see, this wants the vu.name, right? Set the array elements pointer. Okay. So that's that. We probably should also do this. So do that. And then I guess actually we can go ahead and take this for now. but we're going to rename that function. So register. Go to definition. Let's rename this to on registered. Wow, okay. Apparently the refactor failed for some reason. That's fun. Let's see. When this view is registered with the view system. Pointer to the view being registered. All right. Now we can just say on registered. Obviously, we'll have to change all the function pointers, but that's fine. We'll go ahead and also say register view, and then let's spit the name of the view out. Be a little bit more explicit here. View name. I don't know that we should necessarily be doing this here, because the application technically owns this. View passes. I'm going to comment this out for now, because we really shouldn't be doing that here. Right, it's up to the application that owns the view to actually clean up its memory. Okay. All right, so that's everything I think that we need out of here. We do have some checks against this stuff. I don't think... You know what? Actually, some of these are good. I'm going to keep some of those checks. So let's go here. And change that. Change that. Change that. Pass count. Is that... Let's render pass count. Okay. Register. Let's just do this as well. View must have at least one register pass. Render pass. Okay. Oh. How did we miss this one? We could technically use that one too, except instead of config. Oops. View. Pointer to a valid view. Okay. So that's all the sanity checking there as well. And then I'm just going to keep this stuff around as a reference for right now as to what the application itself should be doing. So, I guess what we'll do here is go to testbed main C, and actually we'll need to go to we don't want the game state, we want the application configuration. Oh, that's in the engine probably, isn't it? Configure render views. We want the function. And the application config is passed here, so config your render views config. So game inst app config. That is an application types. Okay. So this is just an array of render views. Render view configs, actually. So let's change this to just render views. And we'll just call this views. First time chat. Mike. How's it going? Welcome. Normally I'm never able to watch your streams live, so this is a nice surprise. Yeah, I'm doing this to sort of make up for the fact that I've missed a few streams lately, right? So I'm kind of hoping to cover a little bit more ground here today. I'm not going to be able to stream on Saturday. I wish I could stream on Saturdays more normally, but today is a little bit of an exception. I have some free time, so. All right, so we have those render views there. An included file. What is this bleating about? Not sure what that's complaining about. All right. So it's render types INL, which I think we are including. So render view known type. The render view config, right. I said I was going to leave this here, but I kind of can't because it's... You know what? I'm just going to rip the band-aid off and nuke it. All right. So that should fix that. So configure render views. So I guess what we need to do here is just basically start building out these views as we normally would. Doing basically these steps, and then pushing them to the array. So we do have config passes for render pass create, so we're still going to want to do that. So we still have this render pass config, skybox config passes. Well, we don't have that anymore, do we? So I guess we're just creating, literally just creating an array anyways. So let's go ahead and say skybox view, right? And then we'll say render view. Skybox view. Should we actually do, you know what? Instead of the config actually holding just an array of render views, now I'm actually thinking how do I want to handle this? This should just be render view. I guess we can still push into that. The thing that I'm questioning is we can create the views themselves, but we have these render pass configs that we have nowhere to actually put now. But all this really does is call this. And we don't necessarily have to call this from within the render view system. So we could probably just create these views and shove it straight into view passes right here in line, instead of creating a configuration object and then passing that through for it to be done later. I'm not sure that that's going to work. We might run into some problems with order of operations with that. I might have to move some stuff to boot instead of post boot. I'm thinking namely about the texture system. Are you working full-time on your engine, or do you have another job as well? So I cannot work full-time on this. I wish I could. But yeah, it's not going to pay the bills. I do have a full-time job that I work during the week. Yeah. That's one of the reasons I can't stream all the time. And, obviously I can only put so much time into this because I do have a full-time job that I have to keep up with as well. So yeah, I'm only able to do this on my spare time. I wish I could work on it full-time, but the money just isn't there. Okay. So let's zero that guy out. So skybox view. We don't have an ID anymore. Type. What is... I didn't think we had type anymore. Did we get rid of type? Oh, it's the known type. I swore we got rid of that. It's gone now. Okay, so we don't need type. We can do name. So in this case, we'll say it is skybox. Do we even look at these view matrix sources? I don't think we do, and honestly, I think I can deprecate those as well. I don't think anything actually uses them. Render view matrix source. Render view matrix. Okay, so those are the sources there. So we set them up, but we're not actually using them. You know what? I'm going to kill those as well. Because that was a configuration thing, and we don't have configuration anymore, and the view can just do it in code. So, on that note, peace. Alright, so I don't need that. So skybox view. The next thing we need is a custom shader name if we use it. In this case, we don't. Just doing that for to be explicit about it, so that it's clear that we've hit everything. Render pass count. So render pass count. What were we doing for that here? Were we just setting it explicitly? Config pass count. Where are we setting that? Oh, we're getting it from the D array of passes. You know what? I'm going to be explicit and not do that. Okay, and we need to allocate some memory for passes. Okay, allocate. Size of render pass. And this, we will actually just use the skybox view render pass count. And then we'll tag this. Memory tag array. Okay. And then what we can do is we can take the configuration, which is here, which actually we can use this directly. Color attachments, attachment count, target count. So we can copy this, put it here. We do not want to do this. So all of this should be the same. Target count, okay. And then render target count. Why do we wait to do this here? Target attachment count. We do a D array. Attachments. We don't need a D array either. Right there. We could just allocate the memory directly because we know how many attachments we have. So there's no point in actually being this flexible with it because we're just creating overhead that we use once and never use again. So this can go up here. Oops, to the pass. So we do that. Oh, wait a minute. Target attachment count. Wait a minute, because the render one can be dynamic. Attachments. Skybox pass, target, attachment count. Target.attachments. Oh, right, this is just one. Okay. So this can literally just be kallocate. Oops, actually I don't even need to delete all that. I can just change this. Size of that. I'm going to put a ×1 in here just to be a little bit more explicit. And then mem tag. Did I tag array? That should be good. Okay. And then since we're doing that, we will treat this one as a pointer instead. And say that this is skybox pass target attachments sub 0, and that's going to be the address of that. So now we can just change these to pointers, do away with that, and then target attachment count can be moved up here, and manually set to 1. Alright, so that wait, what did I do here? This is the old stuff. Okay, so that is all we should need to do for that, and then we should be able to take that render pass config and pass it straight to this guy. So do this in line and say that wants render pass count. So we can use skybox view dot render pass count, and then render pass create is going to be skybox view dot passes sub I, and then oh wait, that's the config it wants. This should be skybox view passes. This one should be the config. Skybox pass. You know what? I don't even need this loop. Why don't we just not do this? Oops, I do need that one. Right, so we can just do render pass. I think this wants the config. So we can just pass it the skybox pass. And I think that's what we need. It looks like my IntelliSense has died, by the way, for some reason. So I'm just going to have to make session, relaunch Vim. I don't know why that happens sometimes, but it does. This is going to be pass 0. Which skybox pass. So once we get past this point, we shouldn't actually need the config anymore anyway. What is this bleating about? Config passes name. So this is going to be skybox view. That passes 0 name. All right. So this is basically what we're going to do for all the views. Is we're going to just change it to that. So, oh, and then we actually need to push it to the appropriate array. So this is going to be config views, and we want skybox view. That should add it to the application config, and then it should be able to pick up on those and register them as needed. If this winds up being too early, I could move this to the on create or on register and do it that way. If too soon in the init process, move to on. Whoops. Whoa. What is that? Move to on registered. What are you doing, Vim? What are you doing? Let's try this again. On registered. Wow, why does it keep doing that? What is going on? Vim is apparently having a conniption today. I haven't updated it recently, so I don't think it's that. I don't know what's going on with it, but... Hydrate. Thank you for the hydrate redeem. Appreciate that. Okay. Just checking messages here. Okay. So, this is basically the process that we're just going to have to repeat for the other views, right? So, instead of creating up all of this configuration for the view itself, we actually do the view creation here. Oh, you know what? I missed a step. I missed the function pointers for that. Missed the function pointers. So before we... Let's do that last. So skybox view, we'll do the on registered. Oh, you know what? We're gonna have to refactor the view as well. Okay, render view skybox. Why did it duplicate that? Okay, you know what? I'm gonna relaunch Vim because it's doing some really weird stuff. Let's do render view skybox. And I guess we'll start in the H file and we will rename skybox on registered. Did it not do it in the C file? Nope. On create. It's basically the same method, we just renamed it. So on registered here is, oh, you know what? I need to include these views. Which I think is fine. These don't need to be in a temp section, so we can say views. Include views. Do skybox first. Include views. We'll do the world next. Then we'll do UI. Oops. Then we'll do pick. All right, whatever. It reordered them, but that's fine. Okay, so skybox view, render view skybox unregistered. That's what we want. And we don't want to call it. We just want to use that, the address of that. All right, so that's the unregistered. So I think the rest of this I can actually copy pasta from over here. So I'll have to change these to I don't know what it did there. Skybox view. Come on. Skybox view. There we go. Set those. The onCreate goes away. And that should be everything we need to do. Tired Beaver, I read your journey as a programmer and it was really inspiring. Huge respect. Thank you for that. I appreciate that. Yeah, it's definitely an interesting path, for sure. And I'm not even halfway done with my journey, I would say. All right. I'm also going to remove these comments because these are sort of unnecessary. Underpass grades. So the register, I think we already have the register up here, right? Yes. Okay. So I really don't think we need much of anything else out of here. I think we can literally just reproduce these steps for everything else. Okay, so that's the skybox view. So as far as this whole section is concerned, that can go away. And I think what I'll do, instead of actually like creating a copy of this, I'll just kind of modify these in place going forward. I'm also going to add these little scoping things here just to kind of keep the scope of these things separate from one another. That way, in case we have any name collisions or anything like that, we don't run into any real problems with that. I don't think that's going to be an issue, but all right, so this is going to be a render view. And we'll call this world view. We will zero this out. We don't have type anymore. Did we set width and height? We did not. Although they're zeroed out anyway, so I guess it's kind of pointless. 0 just means it's going to take up the whole screen, basically. Which when we have an editor, by the way, that's going to change. So, view. We don't have the matrix source anymore. I feel like we're missing some other stuff. So you have the name, custom shader name. Actually, we don't really need this either because that's zeroed out. So we can say render pass count. I think this has 1 render pass. Yeah. So we can set that up. World view render pass count equals 1. Did we set the passes array? I think we did, but we allocated that. So I am just going to copy pasta that guy. So we don't need darray here. All right, and this is going to be world view. Let me give myself a little bit more room here because I don't need that guy quite as much. Okay, so I think all we need to really set up is name, render pass count, and passes at this level. Then we go through our render pass config. I think all of this stuff can stay the same. The only thing we're going to do here is we're going to create size of, manually allocate this, right? Times 1, mem tag array. Because we only have, oh, we have 2 attachments. That's my bad. Okay. Do we actually do We do have attachment count. We should be doing that instead, actually. So we should move this up here instead of getting it dynamically, and then say 2, right? And then use world pass dot target dot attachment count. Did we do that up here? I don't think we did. No. We should, though. That way we don't have more than one source of truth. So we'll change this to skybox pass dot target dot attachment count. All right. So we'll come back down here. So this is going to become pointer to world pass target attachments sub-0, and we want the address of that, right? So take a pointer to that. Oops. And then we can get rid of this. It's a little bit cleaner that way, I feel like. All right, so you know what? While I already have that in the change this to a pointer. The address of world pass target attachments sub-1. Right, and then change that to an arrow operator. Delete that. Render target count is that. This probably, again, should move up here. World pass. Didn't we actually... Did we actually do that up here? Oh yeah, this actually should be a pointer as well. Would have found that at runtime. So this should be skybox view dot passes sub-0, and we need the address of that, which means not what I wanted. All these need to become arrows, including this guy over here. Incompatible pointer types. Oh, wait a minute. That's wrong. This is the config, not the pass itself. Undo. Ignore me. That's the config. We take care of that here. Okay. Right, so the config passes, that actually just goes away. The world config render pass count is here, so that actually goes away. And then config views gets world view passed to it. Okay, so before we pass that over, let's copy all of this there. World pass. and then world view passes sub-0. Did we really leave the... Yeah, we left the error message wrong. Let's do skybox view, and we'll say world view. If I can type, right? This also needs to be world view. Passes name. Okay. Now we just need to do the function pointers, which we already actually have over here. So this is the world one, so we can just grab these guys. And world, whoops. World view. Change these to dots. And on registered, we actually need to go and change this guy. So view world, we'll go here and change this guy. Right. View world C. On create, there it is. Change that. Change this. Okay. There we go. All right. So that is the world view. I think we've covered everything on the world view, so that should be good. The UI view is basically going to be the same thing. And the pick pass is probably going to be the only one that's a little bit different. Just because it has, I should say the pick view has 2 passes, but not a huge deal. So let's scope off this guy. And UI view, and we're just going to call this, actually, UI view. What? All right, type we don't need. Width and height we don't need. Matrix source we don't need. UI view render pass count is going to be 1. And I think that was it. Other than the passes. Yeah. We want to zero this out. And I'm actually going to just copy this guy here. Yoink. Paste that. And then delete that line. UI view. All right. So there's that. Now the pass config. This is going to be a... I think that's actually going to be exactly what we want. So we want to change this to kallocate size of times UI pass dot, isn't it attachment count? Oh, target dot, yeah. Attachment count. We only have an attachment here of, we only have one attachment here, so let's move this guy up. And set that to 1. And we'll move this guy up. Right there. UI target attachment is going to be a pointer now. And this is going to be UI pass target attachments sub 0, and we want the address of that. Which obviously means we need to convert these to arrows. This is pass. That's pushing. We don't need that. UI view passes. That actually gets handled by this logic. Yoink. So put that here. And this is going to be UI pass, and then UI view passes sub 0. Passes a name. So we don't need that. UI view pass count. Should be render pass count, which we already actually have up there, so we don't need that. And then this is just going to be views. We push the UI view into that. All right. The only other thing we need is function pointers. And those we actually happen to have. See, we need the ones for UI, which are here. Yoink. All right. So this is UI view. Unregistered. That means that we actually have to create the unregister for that. So we need to open view UI and come down here. Update that. View UI C. And come down here. Update that. And change it here. Okay. And then we push that into config views, which was config. I think config views wasn't a DRA. I think it was a DRA rather. Okay. The other thing that scoping does, by the way, is if I accidentally leave like world view in one of these things, it actually flags it as an error because it's not within the scope. So I can't accidentally, have a copy pasta error. I do want to take a second and just remind you guys that this is an interactive stream. So if you have any questions about what I'm doing along the way, feel free to jump in a chat and let me know, right? All right, the last but not least is the pick pass. So for this guy, scope it first. All right, and then this is just going to be a render view, and we want to rename this to pick view. Don't need the type, don't need the width, don't need the height, don't need the matrix source. However, we do need, let's see what else, render pass count and passes. So pick view, render pass count, in this case is 2, because we have 2 render passes within the pick. I'm going to grab passes, V, the end of the line, and yank that. Put that here. And this is going to be pick view render pass counts. So we set up our array there. This is the config. So this should be fine as is, with the exception of this guy. So we have a DRA here for attachments. We have 2 attachments for this pass. So allocate size of that thing, right? Times world pick pass dot target dot attachment count, which we need to move. Mem tag array. Right. And the attachment count, I think, is being done down here. It is. So let's move that up. And we can set that to 2. All right, color attachment. So this is the config, right? So it's that. So this is going to be a pointer. And then this is going to be the address of world pick pass target attachments sub-0. We will change this to an arrow operator, and we can get rid of this push. This is going to be very much the same thing, so turn that into a pointer, and then this is going to be the address of world pick pass target attachments sub-1. And then change this to an arrow operator all the way down. And get rid of the push. World pick pass render target count. This needs to be... Right, we're not triple buffering this. So this one needs to just be moved up here. I'm going to put, just to make this a little bit more visible, do that. And then, let's see, so we have pick view passes. So we don't need to do this. We just need to grab this. So we actually need to have this twice. So here is this is the world pick pass. So we need to paste one here. And then one here. Right, so this is going to be world pick pass, and this is going to be pick view passes sub 0. This is going to be pick view passes. Oh, this is going to be pick view, which makes me think I probably missed that up here. This is UI view. Okay, so that should be it for that pass. This needs to be turned into a pointer. So we have the address of, oh wait a minute, this is not the pointer. It's the attachment configs that are. Right, so actually all of this is fine except this guy here, which I'm actually, again, just going to grab a copy of this. Wait, that's render pass count. That's not what I want. This is the one I want, the attachment config. You know what, I'll just do... Where is the attachment count being set? Up here. Let's move this first. We only have one attachment, so we will change that to 1. This will be kallocate size of times UI pick pass target dot attachment count mem tag array. All right, so that is that. This attachment config needs to become a pointer. So this is going to be the address of UI pick pass target attachments sub 0. Change these to arrows. Right. We don't need the push. The render target count for the UI pick pass. Do we not have... I guess we haven't moved that up yet. I'll do like I did for the last one. We're not triple buffering this one either. Pick view passes. So this goes away. This is the, instead of UI pass, it's going to be the UI pick pass. And this is going to be pick view passes sub 1. And then UI view is going to be pick view passes sub1 name. Whoops, sub1. This is also pick view. All right. Pass count. I think this is pick view render pass count. I think we already have that, don't we? Yes, we do. So we don't need that either. And we don't need. Actually, this should just be views. And then we push pick view. The only other thing that we need is the function pointers, like these guys. So I'll come down here, put that here, and we want the pick ones. Yoink. All right. This is going to be UI, or no, just pick view rather. And then these are going to be like that. This is on create is going to be registered. And we have to change this guy. So view pick. So that is going to be on create. And then view pick C. The on create, where is it? There it is. Registered. Okay. This is going to be I removed those on this last one. I didn't. All right. Okay. So we have our function pointer set up. It's being pushed correctly. So I think that is all the conversion that we need to do on this side. Now, I do have these to-dos here. We might wind up having to move those to the unregistered, but we'll see. It might actually make more sense for it to be there anyways instead of us calling it here, but we'll see. Because if we do this during the unregistered, then we can actually technically move all this render pass config stuff over too. So that would actually kind of simplify this a little bit, but also split it up a little bit, which I'm not too keen on. So what I'm going to do now is this render v create. Goodbye. See, it wouldn't want to be you. All right. So we need the render view system H file. And this is going to be create. So we want register. And then we just want a view. And I think conflicting types, B8. Oh, this takes a constant pointer. Do we actually set up anything in here? It probably shouldn't be constant, I'm thinking. Yeah, because that doesn't take a constant pointer, so that's going to be a problem. Okay, so render system view, we are going to get rid of this. Whoops. Okay. So we should be good there. I'm trying to think if there's anything else we need to do. So let's see. Move the concept of render view configuration instead of opting for the function pointers to be filled out with the application as well as all the fields for the view. Did that, and then pass that to the register function. Okay, so this is technically done. Let's write all, and we'll try. Ugh, okay. Building everything. Oh yeah, I figured there's gonna be problems. App config render views. And that's in Systems Manager C. Oh, right. I don't think we changed that. Okay. Was that 289? Render views. We just called it views. Okay. So this should just be views. And then this should be view. And this should be, instead of create, it should be register. Renderview world.h. Okay, we might need to clean. Simple scene. Uh-oh. Simple scene requires render view world? Why? Oh. I thought I searched for these known types and they weren't anywhere. So this actually kind of brings up an interesting point too. So the simple scene actually does have knowledge about packet information. Which makes sense that it would know about what views view it, right? Because it's the one that actually builds the render packet. Simple scene populate render packet. What is actually calling this? So this is actually called by our testbed main. Which makes sense that it would call that. State width, height, p frame data, packet. We're getting the packets here, or we're getting the views here. This almost kind of makes me feel like the scene itself probably also should be managed by the application. Right? Because if we think about it, each application is going to have its own specific rendering needs. So it's going to have its own individual scene needs too. So the whole reason that we have a simple scene is because we're obviously at some point going to have a non-simple scene, right? And so the idea was that we could use like an ECS scene or some other type of scene. Maybe we have a 2D scene instead of a 3D scene, something like that. And that would be aware of what it needs to do to render stuff. So now I'm thinking that the simple scene itself should probably be moved out of the game engine. And it should be up to the application to actually have a scene. Because if we look at this, the application is actually what's driving that render packet population, right? The application knows about its views. The simple scene is pretty specific to the way we've configured this application. So I'm now thinking that it makes sense to actually move simple scene. Because I don't think there's anything actually in the engine that refers to it except... I don't think there's anything in the engine that refers to it at all, actually. If I do a search for simple scene.h, okay, resources, simple scene.c, of course. Okay, that makes sense. Testbed main has it. And the game state has it. So there's nothing in the engine that actually uses it. So there's really no reason for it to be in the engine. It should be in our game code. Okay. So with that, I'm also going to move, let's see, testbed. Oops, actually, we don't want it in testbed. We want it in testbed lib. So if editors views, I feel like just dropping it in the plain source file or source folder is kind of stupid. So maybe we create a scenes folder, because we're going to have a few different types of scenes. All right, I'm going to move it to just the source folder for now, I guess. There's no sense spending too much time thinking about it and overthinking it. Resources. I suppose I could put it under, ooh, you know what? The loader for that is going to be, we do have a simple scene loader, which also would need to be moved. So we'll move simple scene here. You know what? Let's dump it in a resources folder, actually. Whoops. Try that again. Simple scene, resources. Right, and then I can add loaders. And then move our loader for our simple scene to our game code, which is also kind of where it belongs. So it should be this, move to loaders, and this, move to loaders. And then I guess we need our resources system will also have to be changed slightly. So let's see, what do we have right now? So right now, when we initialize the system, we do a resource system loader register right there. So we could technically do that in our application, I think, because we should have ooh, is that not exposed? Oops. It is exposed. Okay. So we should be able to access that in game code. So let's yank this out of here. Testbed main. We'll put this in. We want to put this in boot. I feel like initialize is probably safer. Yeah, I feel like that's much safer. So we can take this, cut that from there, go to the top of this. This is not going to be temporary, so we can put it right here. Right? Now we have our simple scene loader there. Alright, I don't know what happened here. Somehow some random text bound up there. Alright, but let's save that. So that should be fine. Right, and then game state. Oh, game state is going to have to be slightly changed. So let's move this up out of the temp section, and this needs to be quotes there. An included file. Render reviews, render view world. I don't think it needs that. Let's clean build. Resources loader, simple scene loader, resource system.c. Did I not save that file? I probably didn't. Okay, getting closer. Simple scene.h. Unknown type name, render view world data. Testbed main. Oh, let's fix that testbed main one first. So that's line 690. This one we forgot. Mem tag array. All right. Simple scene line 77. So 77. What? Really? Okay. Oh, you know what? Probably simple scene.h has errors. What errors do you have? Render view world data. So it does need to know about that. Okay. I think this is just that though. Loader utils.h. That is simple scene loader. Right, this is going to be sources, loaders, I think. Yeah, okay. And then we're back to the known types. So since we're now dealing with application code, we don't need to have all this type checking. What is all of this? Okay, I think the IntelliSense is freaking out because of the amount of errors. So what is this? 494. Okay. Ugh, God, this is ugly. So we have the packet view count here. And in simple scene populate. Right, so our fix me here is read this from config, where we're getting these every time. And then we're putting these views into the packet. They're always going to be in the same order. But then in our simple scene populate render packet, it looks like we're looping through each of these, type checking them. And then in this one, we're essentially breaking. I think we're doing the same thing. Are we doing the same thing for each one of these? So, right, so the simple scene is picking this stuff out. And it's for some reason doing it in 2 separate loops, which is weird. So in theory, what we really should be doing is accessing these by index. Right, because we know here what indices those are. I should probably enumerate those. All right, so let me start with that. Let's see, this is simple scene. Where should I put that? Let's do a new file. We're going to call this testbed types.h. We're going to open that up. Whoa. I guess we'll paste this first. And then we'll do a type def enum testbed packet views, right? Because testbed knows about that. Why do I have that in caps? Testbed packet views. Packet views. And now I can say testbed packet view skybox equals 0. World equals 1. UI equals 2. And pick equals 3. Whoops, 3. Okay. And then we'll say testbed packet view max equals the last one. Plus 1. Right? So that'll give us that out of the box. And here we can go and include testbed types and change these indices to be testbed packet view skybox, right? Which equates to 0, and that just kind of allows us to very easily access these indices anywhere. So we can testbed packet view world, testbed packet view UI, and testbed packet view pick. And since this is application code, if we ever have to add more views, which we are going to be doing, we can just change up that enum as necessary and access what we need to access that way. So this means that we can do away with these for loops, which is another to-do that we had here, right? Packet views. Read from frame config. I suppose we could do that, but I don't want to set up configuration for this yet. It's application code, right? The application probably doesn't need to configure this dynamically. Now that we think about it, right? You should be able to just do all that stuff in code. All right, so let's remove that. Remove that. Remove this. Remove that. And then this should be packet views. Oh, you know what? We need to include testbed types. Right, and now we can say testbed packet view skybox. Right, and it's always just going to grab the right one. That way we don't have to do this. All we have to do is worry about, grabbing the view packet. And in fact, we only actually have to do we need... Do we need skybox data? So we just load that in. So we technically don't need to do any of these things either. Unless we actually have a skybox. So we can move both of these guys inside of here. And then I'm going to go ahead and... Well, I guess I don't need to scope that one. This next one I think I'm going to scope. So we can delete this, but world render, and then scope. And this is going to be testbed packet views world. Right? And then I don't need this if check, which means I can get rid of one of these guys down here, all the way down here. I think we've done that right. Right, so this is the world render. We go ahead and get that view directly from the index. Okay, cool. So I think we are set on that. And wait, why are we doing... Don't I already have the world? I shouldn't have to be doing... Yeah, I'm doing that here. Render view. Render view packet. So we have view, basically. That's a little confusing. Yeah, we already have view here. So why am I then doing all the way down here another lookup? This should just be view. Oops. Right? Shouldn't be looking that up every frame either. Right? Wonder if that's everything we need to do. I think it might be. Unless I've missed a couple things, which I'm not surprised I have. Missing terminating string and simple scene, line 23. Oh. Right. Okay, so we've built. Well, let's debug and see how much it blows up, shall we? Sweet. Did not open the library. Undefined symbol. Render view pick on register. Undefined symbol. Render view pick on register. Why would that... Render view pick. Oh, it's on registered. Didn't I... Oops. Render view pick on register. That's why. It should be on registered. Which means I probably have this wrong in the H file, I'm guessing. I do. All right, let's try that again. Okay, so we've gotten some sort of D array here that is probably not, oh yeah, some array that doesn't exist for sure. So let's debug this real quick. Draw frame, view on render. Okay, so the function pointer is fine. The view, this is a skybox view. It looks like all of our function pointers have been assigned, so that's good. Passes. Looks like our pass got created correctly. The source seems to be correct. All right, so let's step a little deeper here. D-array length. Data instance updated. Now, why would that not be created? In fact, none of this is created. UI, shader info, world shader info. So let's think about this for a second. So the shaders are going to need the render passes. Which we are creating in line, and that seems to be working. System material. So the render view happens here. Texture system happens here. Technically, all this stuff still should be happening in the same place. Because all we did was change this to... We really just changed the name of this function as to what it's doing. So that shouldn't have really changed it. Shader system is here. So I'm thinking something's probably just happening out of order. But what could that be? Let me check out chat real quick. What is your favorite rendering API? That's a tough question. I would have to say probably OpenGL, just because it's simpler. Vulkan is great, but man, it gets really hard to manage at times. Whereas OpenGL is just kind of handles a lot of that stuff for you. I mean, that comes with its own problems, right? But I definitely feel like OpenGL is a lot easier to use and get started on. So I would probably have to say that's probably still my favorite. It certainly was my favorite before Vulkan came along. I've done a lot of stuff in DirectX and OpenGL in the past, and certainly I always lean towards GL. The only problem with GL is all the legacy stuff that gets in the way sometimes, but... okay, so I wonder... Let me bring my debugger back here for a second. So I assume this is probably on the very first draw frame. It is on the first view that it's running into, so... Render view pick on render. Oh, this data in here is all garbage. Yeah, this is all garbage. But why though? I wonder. Wow, that was not what I wanted to happen. We have testbed main. Let me look through this part where we're sort of configuring all the views, because I'm wondering if I got something wrong in here, like where I'm taking the address of a pointer or something stupid. So we'll focus for now on the skybox view because that's the first one that actually gets hit. So the view is here. Render pass count is 1. Okay, so we do that. We set up all of these things. That should be fine. Set up the attachment count, which is 1. Allocate using that attachment count. Render target count is render window attachment get count. That's probably 3. I'm pretty sure that's going to work correctly. Color attachment. So that's the address of attachment sub-0, and I think that's just an array of actual objects, not an array of pointers. It is, okay. So it's not that. Right, we should have already allocated up here, so that should be fine. Type source load operation present after, okay, that should be fine. Render pass create. Skybox view passes. Right, so that should just take the address of that, and then skybox pass. This takes a pointer to the config, which is skybox pass, the address of that, so that should be fine. So I don't see anything wrong with this. Oh, you know what? Let's double check our console log. Maybe this will tell us something. Nope. So it seems to be fine until the resize. Interesting. So I'm sure it's going to be something purely with this. Okay, we set up our function pointers. And then we add to the D array. So that should be fine. We sectioned each of these off so they don't trample each other. So that should be it. All right, well, I don't see anything here that looks blatantly wrong. So we have skybox view. All right, so let's have a look at I am thinking, well, let's see. View count, views. Oh, app config views. That is a D array, I think. Yes, okay. So we should be able to get the view count from that. Grab a pointer. We register the view. Should be nothing to it. So we take the view in here. View name ID. We set this. Unregistered. We didn't get any failures with this. We regenerate the render targets here. Maybe, oh, you know what? This is happening on a resize though, so maybe it is something in here. Because it was fine until we resize. And that's when it seemed to choke. So maybe there's something in here we missed. View passes. Yep, that just is an array of objects, okay. Render targets, I think, is just an array of structures. Under target create. Pass targets. Okay, so width and height are here. I mean, this should be fine. This is an interesting conundrum indeed. Because it definitely seems legit. Let me clean and build one more time. Data. Self-internal data. Render view pick. So, wait a minute. Wait. Render view pick. Wait a minute. Hold on. Hold on a second. Why is it running render view pick? because I'm an idiot, that's why. Copy pasta for the loss. Updated the first one, but not the others. Noob mistake. Noob mistake. All right, so 5. Actually, yeah. And this actually should be 0. So before I run into any other stupid stuff like that, let me just double check all the rest of these. So world view. These are all the world view ones. UI. Those are all the UI ones. And then pick. These are all the pick ones. Okay. And regenerate should be 0 for all but the pick. Okay, all right. Hopefully that was it. So let's try this again. Hey, what do you know? It works. Well, at least it works here. So let's go ahead and load something up. And it looks like we're up and running, right? Looks like our hovering works as well. So 13, 12 for the car, 11 for the Sponza. If we hover over this text, we get 3. If we hover over this text, we get 4. If we hover over this Kohi, we get nothing, strangely, but that might be ID 0, maybe? I'm not sure. But it looks like our refactor has actually gone well. So visually speaking, we're kind of still in the same place, but now the application is actually in control of how all the views work. So adding a new view wouldn't actually require any engine changes whatsoever. It would be an application change at that point. So this is looking pretty good so far. So I'm going to go ahead and quit out of that and swap back over here. And I'm going to commit this as is. So let's see. We've modified. Okay. Yeah, that added some stuff I didn't want it to add. I wonder if I can just do that. And then testbed lib source game states and testbed main. And then we want source resources. And then testbed types and views. Right. So this editor stuff I don't want to put in there because we haven't talked about it yet. All right. Okay. So let's see, what do we want to say? We want to say refactored renderer view system moved views to application. Also moved simple scene to application. Right, and actually there's one more thing that I forgot to do, which is at the render view system. I forgot to remove this list because we're done with this. Right. So engine status. Okay, get commit removed to do comments. Cool. All right, so we can push this to U origin refactor render view. All right. And actually, I'm going to merge this into main before we do anything else. Man, why is that taking so long? That's kind of scary. I didn't feel like it was that many changes. I hope all this stuff that we just did makes sense to you guys and why we did it. Let's go ahead and pull this down here. Why does it have all this stuff in there? Did we not? That's why. Conflicts. Let's move this up here real quick. Really? What is even the difference here? Am I just blind or am I not seeing a difference? Oh. That. Current. Oh, let's do the H file first. Current, I guess. Not current. I don't know why it's tripping over that. Directional light. Okay, so grid and directional light are up here. Debug geometry. Point lights. There's all that stuff down here. Mesh debug shapes. Yeah, I definitely want current, because otherwise I'm going to have a bunch of duplicate stuff. I'm going to rebuild this and make sure it works before I merge it. I don't know why I'm having such an issue with conflicts today. All right. So it looks like everything here loads correctly. Let me, I guess, just check Sponza. Make sure it has what it is supposed to have at the origin, which it does. It has our light direction thing here as well. Okay, so I think we're good. So let me go back to the terminal here. So git add engine source renderer types. Git add testbed lib source resources. I can just go with a star on that, I think. All conflicts are fixed, but you're still merging. Okay, so git commit merge from main. Okay, now we should be able to refresh this. It should be considerably smaller. Yeah, okay. So this just contains all of the stuff that we've changed today. Okay, so we moved it there, and then, yeah, okay. Okay, so we'll go ahead and create the pull request. And we will squash and merge. I don't know why it contains all this stuff too, probably because I created the branch earlier. Those are the only two commits that are valid. All right. So get checkout main. Get pull. All right. Let's just clean again and build. I just want to make sure this is working on the main branch. It should. It should be. First time chat. Nutella jar. Hey, well, how's it going? Welcome to the stream. Welcome, welcome. How are you doing today? If you're new to the stream, basically what we just finished doing is taking our concept of render views, which control the various aspects of the engine that are being rendered, whether it's the skybox, the world, the UI, or the picking phase. And we've offloaded all that stuff to the application because the application is what should be controlling and configuring all that stuff, as well as actually the scene. So we've just completed that work, and I'm just sort of testing it real quick to make sure that everything is working as it should be, and it looks like everything is. So doing pretty good. Yes, it's your first time hopping in. Okay, cool. Well, welcome. So if you are new to this, I'm not sure if you've seen anything that's going on before, but it'll help to give a quick recap, I suppose. So we are developing the Kohi game engine, which is a series that initially started on YouTube. And it has been going, I think, for a little over 2 years now, where we develop an entire game engine from scratch using C and initially Vulkan as a rendering backend. And so we're going over everything on camera. I switched to actually live streaming this at the beginning of this year. And so it kind of transitioned from being a tutorial series to a live development series. And so that's what this is all about. We have a website, which is kohiengine.com, which kind of gives you links to everything. It gives you links to the YouTube channel, where all these streams are archived afterwards. And of course, the Twitch channel. It gives you a link to GitHub, as well as Patreon and some of those other things. We also have a Discord server that is set up here as well. And then, some fairly newer stuff down here, or updates on the Kohi game engine are here. So this website is kind of light, but it serves as a central hub where you can find everything. This is a completely open source engine. So all the source here is on GitHub, available 100% for free. It is licensed under Apache 2, which basically means that if you use it, you just have to give me credit that you used it, and that's it. We've got a roadmap and all kinds of stuff on here. So what we're doing right now is we've got a basic scene system that's stood up. We've got very basic lighting, basic mesh loading capability. We are doing a little bit of multi-threading, not too much at the moment. And then we've got a bunch of other subsystems that are built into the engine so far. So in fact, if we go to the wiki here, we can actually look at all the features that we've developed so far. So if we go to the wiki main page and then go to the roadmap all the way at the bottom, we can see a list of all of the to-do items that we have listed here, features we want to make. And then UI system kind of gets its own thing. And then this is all the done and implemented features here, right? So we have quite a few things in place. And what we're working towards right now is actually an editor. So everything we're doing at the moment is going through this testbed application that we set up. So whenever we actually run this project, which I use VS Code as my debugger, what we're looking at here is our testbed, right? So we've got some text here, some text here to test. We've got some basic lighting with some debug objects showing bounds and things like that, grid. We have some stats down here at the bottom of the screen. And so this is one application that has been set up to run the Kohi engine. So the goal with the editor is that we are going to create a separate application that is configured differently to the testbed. The testbed is basically to test new features in the engine as we add them. And then the editor is going to be a separate application that works kind of like Unreal Editor, if you think about that. And it's going to provide a world editor for us. And so we'll also obviously have a third type of application, which will be the final game itself that we're going to be making, or collection of games that we're going to be making with this engine once we get to that point. So this is the testbed. Right now it's really the only application, but we are very soon going to be setting up an editor application to use some of these features that we're putting in. So the next thing that we're going to develop, which is going to be used by the editor, but we're going to test it in the test bed is, and I don't know if I still actually have it up or not. Is we are going to be making a Gizmo, right? And I don't think we're actually going to get too deep into this today, just because, you know, the stream has already been going for a while now. So I probably am going to go over some of the off-camera work that I've done with this, but that's probably as far as we're going to get today. So I hope all that makes sense. Riacho, this is impressive. Thank you. I appreciate that. It's a daunting project. You are not kidding about that. Especially to attempt this on your own. It's definitely a lot of work, right? That's why it's kind of taken 2 years to get to this point. If I were using, pre-existing libraries, I probably could have gotten a lot farther, a lot faster. And then again, if I was using OpenGL instead of Vulkan as my backend, I probably could have gotten faster. Or further along faster, but I like to do things the hard way, so it is what it is. With that being said, one of the other goals of this engine is we are going to have multiple rendering backends. So we have a rendering front end that the engine interfaces with, and the back end is what implements our various rendering APIs. So right now, we only have a Vulkan backend, but we are going to be implementing an OpenGL backend as well as a DirectX backend and probably a Metal backend for Apple devices. So this is the next thing that we're going to work on right now is this Gizmo. So a Gizmo basically has, in our case, it's going to be 4 modes. So there's 3 of those modes displayed here. This is actually what 3D Studio Max's Gizmo looks like. So I'm going to kind of somewhat copy this, but make some changes on my own. Theirs has Z pointing up and Y pointing to the side. We are using Y up and Z pointing to that side. So just reverse those in your mind as you're looking at these. But we have a move mode where you can just select an object in the world and be able to move it around on 1 or 2 axes, right? So you can grab it by this guy and move it, or grab it by this guy and move it, or click in between and move them, right? We have a rotation Gizmo here, which allows us to rotate things in the scene. Pretty self-explanatory. And then we have a scale, which we can do 1, 2, or 3 axes. So Y up, yes. Y up is pretty standard for game engines, actually. Just because that's sort of the default that OpenGL uses. Vulkan and DirectX, I think by default, used Y down, I want to say. But we've gone ahead and compensated for that for Vulkan to keep it consistent across the board. Ads. Cool. Let me switch to that. We will continue as soon as the ads are over. We've got about a minute and 12 seconds. Alright, so about 30 seconds more on the ads there. All right, so that's the end of ads. I try to catch that whenever I happen to see it coming, but I don't always catch it. I try not to have the stream going while ads are playing, just so that folks that Have to watch ads, don't miss anything. I don't always catch it, like I said, but I'm trying to get better about it. All right, so I'm very briefly going to cover some of the work that I've done off screen, just so that I can get that into a branch and upload it, but that stuff is not going to work today, and I think we're not going to continue any further today with that. But I do at least want to touch on it. So, let's see, we have... a couple things here. So we have an editor gizmo and an editor view that I started working on. So the gizmo is kind of like the other debug objects that we've created, but multi-layered, right? So we actually have 4 gizmo modes. We have a none mode here. And so the none mode is basically when we have something selected, but we don't necessarily want to edit it in any way. So we want a way to be able to select it, see where it is in the world, maybe pull up some information on a side menu or something about it, but not accidentally move, rotate, or scale it, right? So we actually have a gizmo mode none here for that. And then we have the move mode, the rotate, and the scale modes. And so our editor gizmo structure is here, so that obviously has a mode and a transform as to where it is in the 3D world. And then we also have the gizmo mode data, which for each of these modes we have a separate data structure, which is these guys here, because they all have different visual representations, right? So if I bring back this guy, these look completely different between the modes, right? And we're just going to basically render one mode at a time. Our none mode, incidentally, is going to be just a simple 3-axis control with none of this extra stuff on it, right? And they're all going to be gray, just to make it super clear as to what mode you're in. So that is all that is, and it follows the standard life cycle of most of the other gizmos and things that we've created, debug objects. So we have a create, destroy, we have an initialize, load, unload, update, and we have the ability to toggle the mode. Obviously, we're going to expand on this as we add the capability to hover over the different bits and interact with it and whatnot. This is going to grow quite a lot, right? But for now, we're starting with just the visual aspect of it. So we'll go editor gizmo.c. So in our create, basically all we've done is we default the mode to none. We create a default transform. We go through and we set up some default values on all the modes. And so obviously we have 4 modes. We just loop through those. We just sort of zero everything out, right? We may or may not need indices for some of these things. So our debug objects didn't need indices, but in some cases we may have to draw some triangles, so we may actually wind up having to use indices for one of these modes. So I've put vertices and indices in here, right? Okay, so the destroy, we don't have anything really filled out yet because we don't have everything completely understood as to what we need. We have the initialize, which goes through and again sets the mode to none. I guess that's kind of redundant, but then also creates the gizmo modes, right? So we have one for none, move, and then scale and rotate, right? So we'll kind of step into those in just a second. And then in the load, we go through all the modes. We create the geometry for each mode, and then we set the geometry generation, just as we did in our debug objects. Again, unload, update, we haven't really set those things. We'll be updating those as we create it, but for now we haven't really done much there. We've just sort of scaffolded this, right? And then editor gizmo mode set, all that does is set the mode, and then visual updates will be affected or will come along probably with this update, right? And so basically the idea is we only draw the gizmo for the active mode, right? And then if the whole thing is inactive, we don't draw it at all. So for gizmo mode none, we just create a simple amount of vertices, right? They're all gray. We create one line for X, one line for Y, and one line for Z. For the move, we basically do something very similar, except we use RGB. And then we also have these little boxes that we create along here, right? So I'm not 100% sure haven't seen this run yet, so I don't know that I have the configuration for this right, but I think it's right. The scale, we basically go through here, and all we've done is it looks very similar to the move mode, except it's got this triangle. We're not implementing the inner triangle here. It's basically going to just be this triangle here to indicate when we're doing more than one axis. And then if we're doing all of them, they'll just all be lit up, right? And then rotate, we've gone ahead and generated points for each axis and generating vertices for those points. So I think this code is right, but again, I haven't actually run it yet. And that's all there is to it. We just generate some geometry for each of the modes, feed that to the GPU, and then from there, all we do is just edit that geometry, whether it's editing vertex colors or whatnot, and then moving around its transform, right? And that's all there really is to it, other than the interaction with the mouse and actually, having it interact with other stuff. Let's see. So that is that. And I see that there's chat here, but let me just go through the other file that we have. It's really short, and then we will come back to that. So the other thing that we have is this view editor world. So this is something that I've scaffolded for us to be able to have a different renderer view for the editor, specifically the world editor view. And this is what the Gizmo is going to be drawn in. So this is a very, very lightweight scaffolding, right? It's basically a copy of the world, the world view, except we're basically keeping track of a Gizmo here for now because we don't have an editor to track that for us. So we've got a to-do here that says it shouldn't be owned by the view, but by an editor viewport, because we can technically have more than one. And it's just here for now until the editor's built. We have events, we have our create, and all that stuff, right? So we've hooked most of this stuff up, but we actually haven't hooked the view itself up yet. So that's going to be the next step, right? And so we've done a couple of to-dos, a couple of hacks, just to kind of get things working. And then once we get to the point where we actually start implementing stuff, these hacks will be slowly replaced by, the genuine code that should be there. Okay, and so that is all of the files that we've created thus far. And in fact, git checkout feature editor view Gizmo. All right. Status should be just that. So I'm going to add all these real quick. Git commit initial commit for editor, view, and Gizmo. Right, and I'm going to go ahead and push this so you guys can have it. It'll be available on, of course, its own branch. If I can spell origin. What is it? Feature, editor, view, Gizmo. Cool. All right, so that is now available here for you guys to look at. All right. How would using third-party libraries have helped you? I've been making my own engine off and on and want to take as many shortcuts as possible. So something like a Gizmo, for example, is super complicated to make, and there are libraries out there that do it. However, you're beholden to the way that they do it. So generally that means that you don't have the ability to customize it unless you fork it and customize it yourself and then use that. And then you have to reference that project, and that's all just kind of a pain in the butt. And the whole point of this series is for us to learn how to do this stuff, right? So if we're just using pre-made libraries for everything, we're not really going to learn all that much. But using pre-made libraries would keep you from having to make some of those things. Like another example might be a math library. Like if you use GLM, which is a fantastic library. It's the GL math library is what GLM stands for. But again, we wouldn't have learned the math portions of the stuff that we needed to know if we had just used that. So sadly, I can't stay long, but I'm definitely going to hop in again to check on the project further. Have a great day. See you later. So thank you for dropping in. I appreciate that. Yeah, I don't normally stream on Saturdays, so this is definitely a different thing than normal. But yeah, let's see what pieces of functionality that I've written would I replace. So, I mean, for this project, probably not much of anything yet. There are a couple of libraries, small libraries that I did use, just because it made sense to use those. And they were for things that were really outside the scope of what we need to focus on. So in the engine, we have under source, we have this vendor folder, and we've used SDB image and SDB true type. And so this first one is just loading various image formats into a U8 array that we can then load into the GPU and stuff like that. I didn't see the point of, knowing how to read a file format, an image file format raw. I didn't really see the value of adding that to the series, so I kind of skipped that step. Same is true with STB TrueType. This is to read font files. That is something that is super complicated and pretty low value for a series like this, right? There's not a whole heck of a lot that we would gain from doing that manually. And so we didn't do that manually. We just used that library. But yeah, those are the two that we're using. If I were to replace, probably the only other things I would use libraries for, and I may wind up using libraries for these, would be potentially physics, because that is something you can spend years writing a physics library just by itself because of the complexity there. We may write a lightweight one just to kind of get our feet wet, but that would be one thing. And then another thing would be maybe audio, but we'll see about that. I may write our own, but then I've got to target 3 different platforms, so that's kind of annoying. So I don't know that I want to mess with that. Writing your own fast maths is a big task. I imagine you skipped intrinsics. For now, yes, I've skipped them, but they are in the to-do list. SIMD is on the roadmap for sure. It's just something I didn't need to have sort of in the middle, minimum viable product to get things up and running, but it is on the roadmap for sure. Cool. All right. Well, I think this has been a pretty productive stream. I think we got pretty far today. We accomplished everything I was hoping to accomplish in about the time I wanted to accomplish it. So that is pretty cool. But I think I'm going to go ahead and probably end it here. Again, if you guys want to toss me a follow so that you see whenever I'm on, I'll be streaming on Twitch. I normally stream on Wednesdays and sometimes Thursdays. And then, of course, all of these videos will be archived to YouTube after I've passed, the limit that Twitch has that we have to wait. Awesome. This approach sounds like a good fun. Thanks for documenting it. Yeah, no problem. I'm hoping that folks are able to learn from this and gain a lot from it. But yeah, if you guys want to support my work, you can always head over to Patreon. I have a Patreon page there, patreon.com/Travis Vroman. Or you can become a member on the YouTube channel. Either way, I also have a Kofi page. But don't feel like you have to do that. It just, anything that I get there, I do wind up reinvesting back into the stream. So, for example, I was able to take about a year and a half worth of funds from that to get a Mac to be able to port this engine and test it on that device as well. So, yeah, stuff like that, better video equipment, audio equipment, stuff like that. So anyway, I think that's going to do it for today. Thank you guys so much for hopping on the stream and interacting and following along. I really appreciate you guys. And let's go ahead and look for a channel to raid. Let's see. So those of you who have followed me for any amount of time probably know who I'm going to pick here. But I'm going to raid Ferret Software because their owner, the owner of that channel, is Pirate Software, and he is creating a rescue for ferrets. He basically takes all the money that he gets from this channel and takes all the ferrets that he's rescued and uses it for their medical bills. And he's got, I think, 13 ferrets at the moment. Some of them who have health issues that the funds from this are paying for. So I'm going to go ahead and raid his channel. And yeah, thank you guys so much for following along. And I will see you guys later.